Bubble sort is one of the well-known sorting algorithms because it is straightforward. It is a comparison-based algorithm in which each pair of adjacent elements is compared and the elements are swapped if they're in the wrong order. While the bubble sort is not fast enough in practice for all but the smallest datasets, it does handle the purpose of showing how a sorting algorithm works. Typically, it looks something like this. This algorithm is named for the way the big bubbles float to the top of the list on every step. The formal bubble sort algorithm is as follows. First, compare each pair of adjacent elements from the beginning of an array, and if they're in reversed order, swap them. Second, if at least one swap has been made, repeat the first step. It means that the pass through the list is repeated until no swaps are needed, which indicates that the list is sorted. Let's see an example of sorting an array to make the idea of bubble sort clearer. We will take array of cards 5, 2, 4, 3, 8 and sort the array from lowest number to greatest number using bubble sort. In each step, cards presented in dark red are being compared, and cards presented in light red are being swapped. Here, the algorithm compares the first two cards and swaps since 5 is greater than 2. Next, we compare 5 and 4 and it swaps because 5 is bigger than 4. Next, it swaps since 5 is greater than 3. Now, since 5 and 8 are already in order, the algorithm does not swap them. Now we have finished the first part of the algorithm, and since 3 swaps have been made, we repeat the first step and proceed to the second pass. 2 and 4 are in order, so we move to the next two cards. 4 is greater than 3, so we swap them and proceed. 4 and 5 are in order, so we move to the next two cards. 5 and 8 are in order, and now we have finished the first part of the algorithm, and since one swap has been made, we repeat the first step and proceed to the third pass. Now the cards are already sorted, but the algorithm does not know if it is completed. The algorithm needs one whole pass without any swap to know it is sorted. It goes through every set of adjacent cards in the third pass without any swap, and the algorithm terminates with a set of sorted cards. Although the bubble sort is simple, it is too slow and impractical for most of the problems. Bubble sort's average and worst-case complexities are O of n squared, which makes it quite inefficient for sorting large data volumes. Let's see an example of sorting a small unsorted set of 5 and a large unsorted set of 10. Since the time complexity is O of n squared, and being the number of items being sorted, it looks like sorting the large set takes 4 times longer than the small set. Next, the bubble sort is a stable sort, which means that the sets maintain relative order of records with equal keys. Here's an example where there are two sets of equal length within an unsorted set of 10. It looks like two equal sets maintained their order. Finally, bubble sort is adaptive, which means that for an almost sorted array, it gives O of n estimation. Let's see an example of sorting an unsorted set and an almost sorted set. Even though there are the same number of sets, the random set takes around 5 times longer. I have explained the bubble sort algorithm in full detail, and to conclude, I will point out the main characteristics. First, a bubble sort is a comparison-based algorithm in which each pair of adjacent elements is compared and the elements are swapped if they're in the wrong order. Second, bubble sort's average and worst-case complexities are O of n squared, which makes it quite inefficient for sorting large data volumes. But its best-case complexity is O of n, which makes this algorithm adaptive. Third, bubble sort is stable. And finally, it doesn't require memory space. Well, that's bubble sort for you. There's a Python code for bubble sort in the description below in case anyone wants to examine how it's coded.